Good afternoon, students. In the previous class, we learned the topic physical and chemical equilibrium. What is meant by physical and chemical equilibrium? Physical and chemical equilibrium. See, now we can learn the next topic, dynamic nature of equilibrium. Your next topic, dynamic nature of equilibrium. Dynamic nature of equilibrium. To explain this dynamic nature, first we can see one simple example. Listen, you consider a building. You consider a building. You consider a building. Here 10 number of people, some number of peoples are moving from first floor to second floor. For example, here some number of peoples are moving from first floor to second floor. At the same time, same number of peoples are moving from second floor to first floor. See, consider one building there. Say some number of peoples are moves up from first floor to second floor. At the same time, same number of peoples are moved down from second floor to first floor. If you are seeing the rate of movement of peoples from first floor to second floor is equal to the rate of movement of peoples from second floor to first floor. Rate of movement of first floor to second floor. Rate of movement of peoples from first floor to second floor is equal to the movement of peoples from second floor to first floor. First floor to second floor people, that movement is equal to the second floor to first floor. Understand? Now from this we can tell the topic, number of peoples in each floor will remains the same. Number of peoples in each floor will remains the same. Number of peoples in each floor will remains the same. First floor to second floor and second floor to first floor. The rate of movement of peoples from first floor to second floor and second floor to first floor is equal, same. So we are telling the definition. We can tell the definition at equilibrium. At equilibrium. At equilibrium, both forward and backward reaction are at the same rate. Both forward and backward reactions. Both forward and backward reactions are at the same rate means. Here we explained rate of movement of these two remains the same, isn't it? So from this we are telling the definition correctly. At equilibrium, forward and backward reactions, both forward and backward reactions are at the same rate. Tell the definition, dynamic equilibrium. At equilibrium, both forward and backward reactions are at the same rate. So we are telling chemical equilibrium is referred to as dynamic equilibrium. This one is referred to as dynamic equilibrium. Understand? So why we are telling this is dynamic equilibrium? Tell the answer. At equilibrium, both forward and backward reactions are at the same rate. Understand? Okay, see. Now we are next topic, types of equilibrium. Types of equilibrium. There are two different types of equilibrium. There are two different types of equilibrium. One is homogeneous equilibrium and another one is heterogeneous equilibrium. So two types of equilibrium. One is homogeneous equilibrium and another one is heterogeneous equilibrium. See here, the first type is homogeneous equilibrium. Your first type, homogeneous equilibrium. What is meant by homogeneous? You know, homo means same. So homogeneous means all reactants and products are in same phase. All reactants and products are in same phase means we are telling that is homogeneous equilibrium. Both the reactants and products are in same phase. You can see one simple example. Hydrogen reacts with iodine gives hydrogen iodide. Hydrogen reacts with iodine gives hydrogen iodide. In this example, hydrogen gas, iodine gas and hydrogen iodide gas. Understand? Here both reactants and products are in gaseous phase, same phase. So we are telling that is homogeneous equilibrium. See one simple example, both hydrogen and iodine are gas phase and same way product hydrogen iodide also gaseous phase. So both the reactants and products are in same phase. Both the reactants and products are in same phase. Understand? Then second type, heterogeneous equilibrium. The second type is heterogeneous equilibrium. What is meant by hetero? Hetero means different. Hetero means different. So heterogeneous means both reactants and products are in different phase. Both reactants and products are in different phase. Both the reactants and products are in different phase. Here we can see one simple example. Water molecule liquid is converted to water molecule vapor. Water molecule liquid is converted to water molecule vapor. Here reactant liquid phase, product gas phase. So reactants and products are in different phase. Understand? So listen. Two types of equilibrium, chemical equilibrium we learn. One is homogeneous equilibrium and another one is heterogeneous equilibrium. What is meant by homogeneous equilibrium? All reactants and products are in same phase. All reactants and products are in same phase. Simple example, this one gas phase and product also gas phase. Then second type, heterogeneous equilibrium. What is meant by heterogeneous equilibrium? All reactants and products are in different phase. All reactants and products are in different phase. Simple example, liquid and gaseous phase. So reactant side liquid, products in gaseous phase. Understand? So this are only types of equilibrium. Types of equilibrium. Understand? Okay, listen. See now your next topic, law of mass action. Law of mass action. In the year 1864, two Norwegian chemists, Maximilian Guldberg, two scientists, Maximilian Guldberg and Peter Wage, Maximilian Guldberg and Peter Wage. So in the year 1864, two Norwegian chemists, Maximilian Guldberg and Peter Wage. These two scientists only explain the topic law of mass action. These two scientists only explain the topic law of mass action. What they explain means, the statement is, listen, the rate of chemical reaction at a given temperature is directly proportional to the active mass of reactants. Active mass of reactants. The statement is, at any instant, rate of chemical reaction is directly proportional to the active mass of the reactants. Active mass of the reactants. Understand? So listen. In the year 1864, two Norwegian chemists, Maximilian Guldberg and Peter Wage. These two scientists only explain the topic law of mass action. What they explain means, the statement is, the rate of chemical reaction is directly proportional to the active mass of the reactants. Rate of chemical reaction is directly proportional to the active mass of the reactants. Understand? And here you can write the formula correctly. Concentration of active mass of reactants power X. Here this power X, this one represents the stoichiometric coefficients of this one represents the x represents the stoichiometric coefficients of reactants. Stoichiometric coefficients of reactants. For example, AA gives BB means stoichiometric coefficient of reactant is stoichiometric coefficient of reactant A is the small a. So this X represents stoichiometric coefficients of reactants. Stoichiometric coefficients of reactants. Understand? Then this square bracket represents the active mass of the reactants. Square bracket represents the active mass of the reactants. Understand? So now we can tell one more formula, active mass. Active mass is equal to N by V. Active mass is equal to N by V. Unit we can say mole per decameter cube or mole per liter. Mole per decameter cube or mole per liter. So tell the statement law of mass action. Rate at any instant, rate of chemical reaction is directly proportional to the active mass of the reactants. Active mass of the reactants. So we can tell the explanation. X is stoichiometric coefficients of reactants. X represents stoichiometric coefficients of reactants. Then the square bracket represents active masses of the reactants. Active mass of the reactants. So we can tell the formula active mass. Active mass is equal to N by V. Active mass is equal to N by V. Unit mole per decameter cube or mole per liter. Understand this topic, law of mass action. Law of mass action. Here the statement is important. One more time, can you tell the statement? At any instant, rate of chemical reaction is directly proportional to the active mass of the reactants. Understand? Okay, see now take page number 4. Page number 4. Dynamic nature of equilibrium. This is important 2 more question. The first paragraph, just read this. This is enough. Explanation only they given. Page number 5. This one only important 2 more question. Why this chemical equilibrium is referred to as a dynamic equilibrium? Answer this paragraph. Page number 5. Second paragraph. Chemical reactions which are reversible do not case. When equilibrium is attained, at equilibrium, the forward and backward reactions are proceeding at the same rate and no macroscopic change is observed. So we are telling this is dynamic equilibrium and one simple example, equilibrium example. So this paragraph only. So from this to chemical reactions, from this to till this hydrogen iodide. Why this chemical equilibrium is referred to as dynamic equilibrium? Understand? Then in the same page, next topic, types of equilibrium. Types of equilibrium. Just note the answer from this to homogeneous equilibrium. Note the answer. First definition. Then example. Till this. So first in homogeneous equilibrium, all the reactants and products are in the same phase. And write this example. Here H2, I2 and HI are in the gaseous state. Till this. One more example they given. If you are expecting, try to write that also. Then second one. First till this gaseous state. Then right side, same page, right side, heterogeneous equilibrium. From this to till this carbon dioxide gas. Read this. If the reactants and products of a reaction in equilibrium are in different phases, then it is called as heterogeneous equilibrium. And just note this example. So till this. Understand? The next question. Law of mass action. This also important 3 more question. State law of mass action means, this is the statement. At any instant, the rate of a chemical reaction at a given temperature is directly proportional to the product of the active masses of the reactants at that instant. Rate is proportional to reactant power x. Just write the explanation. X and act square bracket. X is stoichiometric coefficient of the reactant. Square bracket represents the active mass of the reactants. and write the formula. Active mass means N by V, mole per decameter cube or mole per liter. Then next page number 6. Page number 6, just explain this N and V. N is number of moles, V is volume of the container, decameter cube or liter. Understand? So just note the answer till this liter. State law of mass action means if it is 2 mark question, this is enough. At any instant to till rate is proportional to reactant power x. If it is 3 mark question, from this to at any instant to till page number 6 till this liter. Understand? See, listen. Now the next topic, equilibrium constants Kp and Kc. Derive the term equilibrium constants Kp and Kc. How we can derive this Kp and Kc? First, consider a chemical equilibrium reaction. You consider a reversible reaction. One of the simple reaction, Xa plus Yb gives Lc plus Md. You consider a reversible reaction, Xa plus Yb gives Lc plus Md. Here in this equation, A and B are the reactants. A and B are the reactants and C and D are the products. A and B are the reactants and C and D are the products. Here X, Y, L, M are coefficients. Stoichiometric coefficients of reactants and products. Stoichiometric coefficients of reactants and products. Understand? Now listen, here apply the law of mass action. Apply the law of, just applying the law of mass action. If you are applying law of mass action, you know the formula law of mass action. Rate is directly proportional to concentration of active mass of reactants power X. Like this you can write the formula. Can you tell the formula? First, separately you can write the forward reaction and backward reaction. This is forward reaction and this is backward reaction. So can you tell the formula? Rate of forward reaction, symbol we can write RF. This is directly proportional to active mass of reactant power coefficient. So here reactants A and B. So you can write active mass of reactant power coefficient X into active mass of B power Y. Understand? Here you can replace the proportional term and you can add the constant. So if you are replacing the proportional term, you can write the formula Rx equal to Kf. Introduce the constant K. So Kf into concentration of A power X into concentration of B power Y. Understand this? Replace the proportional term and add the constant K. Forward reaction, so we return Kf. Understand? The same way you can write the backward reaction. Rate of backward reaction is Rb. So Rb is equal to product C. Here backward reaction means C and D only reactants. So you can write, first write proportional. Proportional active mass of C power L. Product only reactant. Backward reaction means into one more reactant. Active mass of D power M. You can replace the proportional term. So you can write Rb is equal to Kb into active mass of C power L into active mass of D power M. Understand? See here at equilibrium. You got the formula now. Rate of forward reaction and rate of backward reaction. Now at equilibrium, rate of forward reaction and backward reactions are same. So rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. So you can substitute the formula. Can you tell the formula? Rate of forward reaction Kf into concentration of A power x into concentration of B power y is equal to RB Kb into concentration of C power L into concentration of D power M. Understand? Now take the K terms, constant terms in one side, the concentration terms in another side. So take this Kb this side, this concentration right side. So can you tell the formula? Kf, this Kb this side. So Kf divided by Kb is equal to concentration of C power L into concentration of D power M divided by concentration of A power x into concentration of B power y. Understand? Now listen, in this equation, this Kf by Kb is equal to Kc. Kf by Kc is equal to Kc. So now we can substitute this value. Kf by Kb is equal to Kc. So Kc is equal to concentration of C power L into concentration of D power M divided by concentration of A power x into concentration of B power y. So this is only equilibrium constant Kc. Equilibrium constant Kc. So can you tell the definition? You can tell the definition. Equilibrium constant Kc is defined as ratio of concentration of product to the concentration of reactants. Or you can say the definition, ratio of active mass of product to the active mass of reactants. Understand? So from this easily directly you can write the Kp formula. Kp means instead of concentration, instead of square bracket, introduce the term pressure. Instead of concentration, square bracket, introduce the term pressure. So how we can write the formula? Instead of square bracket you write P. P of C power L into P of D power M divided by, here also you can write P of A power X into P of B power Y. So this one only Kp. So this is the derivation Kp and Kc. Kp and Kc. Understand? Okay, see, now take page number 6. Page number 6. Derive the equilibrium constants Kp and Kc. Derive the equilibrium constants Kp and Kc. Note the answer from this two. Let us consider a reversible reaction. Xc plus Yb gives Lc plus Md. Here A and B are reactants, C and D are products. X, Y, L, M are coefficients of these terms respectively. Then if you are applying law of mass action, rate of forward reaction is equal to, rate is directly proportional to active mass of reactants. So we can write separately forward and backward. At equilibrium, forward and backward reactions are equal. So if you are applying, you got the answer Kc. And just they given the Kc definition. Kc is defined as, at a given temperature, the ratio of product of active mass of reactant raised to respective coefficients in the balanced chemical equation to that of the reactants is constant. The next continuously we can write pressure formula also. Okay, if the reactants and products of the above reaction are in gaseous phase means, we can write Kp is equal to, instead of bracket we return P. So Pc power L, Pd power M divided by Pa power X, Pb power Y. Here these are the terms are partial pressures of A, B, C and D respectively. Understand? So this is one of the important topic. Equilibrium constants Kp and Kc. Equilibrium constants Kp and Kc. Understand? Okay, listen. Now the next topic. Relation between Kp and Kc. Relation between Kp and Kc. This is one of the important 5-mark question. So listen, here first consider a general chemical equilibrium reaction. Consider a general chemical equilibrium reaction. You consider a same reaction XA plus YB gives LC plus MD. You consider a reversible reaction XA plus YB gives LC plus MD. Here at equilibrium you can write the formula Kc and Kp formula. Now only we derive the two formulas, so directly you write, you know the formula, concentration of C power L into concentration of D power M divided by concentration of A power X into concentration of B power Y. Same way write the formula Kp. Tell the formula Kp. Kp is equal to pressure of C power L into pressure of D power M divided by pressure of A power X into pressure of B power Y. Understand? Now listen. You know the ideal gas equation. Ideal gas equation. Ideal gas equation is, tell the ideal gas equation, PV is equal to nRT. PV is equal to nRT. Find the pressure formula. P is equal to N by V into RT. P is equal to N by V into RT. N by V formula already we learned. N by V is equal to active mass. N by V is equal to active mass. So tell the formula, pressure P is equal to active mass into RT. Pressure P is equal to active mass into RT. Understand? Now listen. This is commonly pressure. Here pressure of 4 terms are there. So separately we can write all the pressure formulas. So PC power L. PC power L. See, pressure of C power L. So separately we can write active mass. Active mass of C. So you can write the formula active mass of C power L into RT power L. See, this is the formula pressure. So separately we can write all the formula. So P C power L is equal to C power L into RT power L. Understand? Same way you can write the other terms also. P D power M is equal to concentration of D power M into RT power M. Same way tell the next two formulas also. PA power X is equal to concentration of A power X into RT power X. Then PB power Y is equal to concentration of B power Y into RT power Y. Understand? See, pressure formula active mass into RT. Separately PC power L, PD power M, A power X and B power Y. Separately all the formulas we can write. Understand? See, now substitute all the pressure values in this Kp equation. Substitute all the pressure values in this Kp equation. So can you tell the formula Kp? Kp is equal to PC power L formula, concentration of C power L into RT power L into PD power M is concentration of D power M into RT power M divided by PA power X, concentration of A power X into RT power X into PB power Y is concentration of B power Y into RT power Y. Understand? Now listen. From this, take the RT terms. Take the RT terms separately. So how we can write the formula? Kp is equal to RT power L into RT power M into C power L D power M divided by RT power X into RT power Y into A power X into B power Y. Understand? See here in this equation, rt power l into rt power m divided by rt power x into rt power y. So this is similar to a power x into a power y. A power x into a power y means you can write the formula according to mathematics, a power x plus y. So this one you can write like this, Kp is equal to rt power L plus m into, this is concentration of C power L, concentration of D power m divided by, this also you can write, RT is RT power x plus y into a power x into b power y. A power x into b power y. Understand? Now see this equation you can write, mathematics you can write, a power x divided by a power y is equal to a power x minus y. So a power x divided by a power y. So this one you can write rt power l plus m minus x plus y into, this one you can write, concentration of C power L, concentration of D power m divided by concentration of a power x, concentration of b power y. Understand? Kp is equal to this one. So this equation, this formula already you know, Kc formula. Tell the formula Kc, concentration of C power L, concentration of D power m divided by concentration of a power x, concentration of b power y. You can substitute this Kc value. So tell the formula Kp. Kp is equal to concentration of RT power. See this one you can consider L plus m minus x plus y is equal to delta Ng. Let's consider that. So you can write the formula RT power delta Ng into Kc. This is Kc. Understand? Just rearrange and write the formula. Kp is equal to Kc into RT power delta Ng. So this is the relation Kp and Kc. Relation between Kp and Kc. Relation between Kp and Kc. Understand? Then see, continuously we can learn the cases also. 3 different cases. First case is delta Ng value 0. Delta Ng value 0. Delta Ng means formula you know, L plus m minus x plus y. L plus m minus x plus y. L and m are stoichiometric coefficient of product minus stoichiometric coefficient of reactant. Stoichiometric coefficient of product minus stoichiometric coefficient of reactant. So first consider in this equation, you consider ensemble example, hydrogen plus iodine gives hydrogen iodide. Hydrogen plus iodine gives hydrogen iodide. See the example, hydrogen plus iodine gives 2 hydrogen iodide. Here can you tell the coefficient of product? Product coefficient 2 and reactant coefficient hydrogen 1 and iodine 1. So you can calculate delta Ng. Tell the formula delta Ng. Delta Ng is equal to product coefficient 2 minus reactant coefficient hydrogen 1 and iodine 1. Tell the answer, 2 minus 2 is equal to 0. So delta Ng value 0. Can you substitute the formula? You know the relation. Kp is equal to Kc into RT power delta Ng. Substitute the delta Ng value. Kc into RT power 0. Anything power 0 means 1. So is equal to Kc. So you got the answer, Kp is equal to Kc. Understand? This is the first case. Then second case, delta NG value positive. Delta NG value positive. Here you consider the example. One simple example. PCl3 gives PCl5 gives PCl3 plus Cl2. PCl5 to form PCl3 plus Cl2. Here how we can calculate delta Ng? Delta Ng is equal to product coefficient PCl3 1, chlorine 1 minus PCl5 1. So tell the answer 2 minus 1 is equal to 1. Now you can substitute the value. Formula Kp is equal to Kc into RT power 1. So your answer Kp is equal to Kc into RT. Understand? So Kp is equal to Kc into RT means you can write the symbol Kp is greater than Kc. Kp is greater than Kc. Understand? Then one more case, one more condition, delta Ng value negative. Delta Ng value negative. Here you can consider a simple example. Hydrogen plus oxygen gives water molecule. 2H2O, 2H2. Here can you tell the value delta Ng? Delta Ng is equal to product 2 minus here 2 plus 1. So your answer 2 minus 3 is equal to minus 1. Can you substitute the value? Tell the formula Kp is equal to Kc into RT power minus 1. So you will get the answer Kc divided by RT. So this relation you can write Kp less than Kc. Kp less than Kc. So this is the cases relation between Kp and Kc. Understand this? Now take page number 6. This is important 5 mark question. Derive the relation between Kp and Kc. Note the answer. Let us consider the general reaction from this to first general reaction Kp Kc. Then page number 7. Ideal gas equation. From that pressure formula. Then separately they written all the pressure. Then if you are substituting, you got the answer. Relation Kp is equal to Kc into RT power delta Ng. Just to write the explanation delta Ng. Difference between sum of the number of moles of product minus number of moles of reactants. Then the 3 cases. These 3 cases also important. First case delta Ng value 0. Delta Ng value 0 means you got the answer Kp is equal to Kc. Kp is equal to Kc. Then delta Ng value positive means Kp greater than Kc. Delta Ng value negative means Kp less than Kc till this. So this relation is very important. Page number 6. Relation. Let us consider from this to till page number 7. Right side till Kp is less than Kc. Understand? Any doubt? Now note the homework portion. Tomorrow's homework. Today's portion filling. First page number 5. Why this one is referred to as dynamic equilibrium. Then types of equilibrium. Then state the law of mass action. Then page number 6. Equilibrium constants Kp and Kc. Then the same page derive the relation Kp and Kc. Understand? These are the questions. Learn thoroughly. Okay, thank you.